you're doing great. Our today's question is subsets 2. So the question says, given a collection of integers that might contain duplicates, nums, return all possible subsets, the power set. The solution must not contain duplicate subsets. So the given input is 1, 2, 2, and we can see that these are the possible subsets without any duplicates, which we need as an output. So I've created a video on subsets problem, which is pretty similar to this, and it's like kind of a starting point. So I would recommend you to go and have a look at that. So as we discussed in that video, we were talking about backtracking being a possible solution whenever the question needs you to return a possible combination of the answers, right? So for example, if the question here says return all possible subsets or return all the possible sub-arrays, or for example, combination sum, those are classic examples of backtracking. So this is a characteristic that you can identify whenever you are thinking about a backtracking solution. If the question needs you to find the count of the possible ways or the min or the max, then it's probably just a simple array traversal, or it could be DP or greedy. It's really unlikely that it would be backtracking. So that's just a tip. So for this, we'll be using backtracking. We would be starting with every number, right? We don't want to process any number twice. So we will start from 0, and then in our recursive function call to the backtracking function, we'll always be starting the next iteration from I+1, so that we don't end up using the same element twice. After that, once we're done with that, here we can have duplicates in the given input, whereas in subsets we did not. So the only change that we'll need to make here is that, one, we'll have to sort the array, and after sorting we would know that if there are duplicates, they'll be adjacent to each other. So whenever we are processing them, we'll just make sure that before adding it to the temporary list that will contain our subset, we would not add it if this particular element is the same as the previous one. So that will help us avoid adding any duplicates. So the code will make it pretty clear. Let's get started. Oops. Ooh. Yeah. So list of integer result equals to new array list of integer. Yeah. Okay. If the nums length is equals to 0, then we just return this blank result, right? Okay. Otherwise, as I said, we'll do an arrays dot sort and sort nums first, and then just the similar way we'll just call dp. So our starting point would be 0. We'll give it a new integer array list, and we'll give it nums. Okay, and then we'll return result. Okay, now and then we implement the bt function. So we'll get a start, we'll get a array list of integer, which we'll call current, and then we'll get this. Cool. So we'll have to add this to, yeah, so we create a new array list of integer and pass current. So you cannot do a direct result.add current because it references to the same object. You'll have to create a new array list and then use current to populate that array list and add it to results. You can just sit and try that, but yeah, that doesn't work. Okay, so after this we'll just do a start, and we'll go till nums length, right, and I++. Okay, so Now here is where we're going to be trying to avoid the duplicates. So we'll just check that if I is greater than start, okay, and nums of I minus 1 is equal to nums of I. So why we are doing this is because we know that since the array is sorted, if there are two numbers which are same, right, they'll be adjacent to each other. And like if I am at the start, I don't want to skip that particular number. So I want to skip it only if I am getting, like, I've processed two ones and then I'm getting 2 after that. So I want to just skip those elements. So I don't want to do this while I is equal to start. Plus this also helps us in making a check on if I is equal to 0, right? So we will not end up having a 0 minus 1 situation here. Okay. So if that's the case, just continue and don't use this nums of I. Otherwise, we'll just do the same thing as subsets. So we'll just add to this nums of I, the way we're adding there. And then we'll just do a backtracking and we'll be basically send I plus 1 because we don't want to use I again, right? And then nums. And then we'll remove the last element that we just added. So current dot size minus 1. Yeah. Cool. That kind of looks in place. Let's see if that works. It works.